One of the characteristics of solids, and other states as well, I should say liquids, is that they have what's inherently called specific heat. And specific heat is how much heat I have to add, and we measure that in calories or in joules. How much of that energy is needed to raise the temperature of a gram of whatever substance I'm looking at by 1 degree C. So specific heat is the amount of heat required to raise the temperature of 1 gram by 1 degree C. And so specific heat is the heat that we add in calories or joules divided by the mass in grams times delta T. And if you recall, delta T means what? Change in temperature. So you'd have an initial temperature and a final temperature, and the difference between those is going to be your delta T. The larger the specific heat, the less its temperature will change when it absorbs a typical amount of heat. That should say amount, not about. All right, so it's the larger the specific heat, the less it's going to absorb of heat when you add heat to it. So everything has a specific heat, and so we're looking at solids here. So aluminum, and we'll just look at joules. Remember, it's heat divided by grams times heat. Temperature. So joules divided by grams times degrees C. That's why it has those units. All right. So aluminum has a 0.895, carbon 0.707, ethanol really high, 2.44, and that's one of the reasons is because it has hydrogen bonding. 2-propanol also has hydrogen bonding because alcohols have an OH group attached to them. Water, look how high water is, because it's the most hydrogen bondy thing we have, right? And that's why so many things will dissolve in it. And notice that the liquid is the highest. Okay, so, but the point here is everything has a specific heat, and the stronger your intermolecular force is, stronger the bonding is, then the higher that specific heat is going to be. And remember what we said, the larger the specific heat, the less the temperature will change when it absorbs heat. So if we work a specific heat problem, it's going to ask you how much heat you add to something. So how many calories are needed to heat a pot of 1,600 grams of water from 25 degrees to 100 degrees. All right. So I'm going to rate. I got 1,600 grams. I'm going to raise it from 25 to 100. All right. So I'm given the mass of 1,600 grams. I'm given an initial temperature of 25, a final temperature of 100, and I want to know how many calories it's going to take to do that. So first I have to know what my delta T is. All right. So my delta T is going to be 100 degrees minus 25 degrees, and that is 75 degrees. So that's my delta T in degrees C. I know that the specific heat of water in calories, and I should have shown you this in that table, is 1 calorie over gram degree C. I'm so used to using joules. Let me just show you that right here. Water's the highest one of anything. So that's why water we say is 1, and then everything else is less than that, so it's a decimal. All right. So the specific heat of water is 1 calorie divided by grams times degrees C. So when we do specific heat, we have that the heat that we must add is equal to the mass times the delta T times the specific heat. Right? So calories are going to be equal to the grams of the substance we have times the delta T, the change in temperature, times the specific heat in calories over gram degrees C of that material. And we're talking about water, so that's going to make this one's pretty easy. 1,600 grams times the delta T of 75 degrees C times 1 gram over 1 calorie, over 1 gram degrees C. And then that allows us to cancel degrees C and cancel grams. And remember, that's what constants do. So specific heat is like a constant. And it's going to leave us with the units of calories, which is what we were looking for. And so that is going to give us 1.2 times 10 to the 5 calories. So remember, water is the highest specific gravity of all. Specific heat, sorry. I don't know what's wrong with me. All right. And it's a 1 calorie over gram times degree C. All right. So remember that, because a lot of times your problems are going to involve water.